Alright, so this is my week 4, problem number 4 video explainer. It's my second video. So in this example, we have a hydraulic press with 2 pistons, one on the left side and one on the right side, and we have a mass of 1,000 kilograms being applied to the right side on that piston. We are also given the areas of each piston, and we are trying to find what the value of the force on the left side of the piston, or left side of this hydraulic press will be. And I just denoted some of the variables in this diagram. So there was nothing that stated whether or not there was liquids of different densities in there, so we know that the pressure on both sides will be equal. And knowing that, we can derive a way to solve for the force. So we know that pressure is equal to force over the area. So, and we were given the areas of those 2 pistons. So the smaller one being 5.0 times 10 to the negative third meters squared, which we find is pretty small. And the area of the other one is 1.0 meters squared. So after moving around some of the variables from that, the pressure of the first side equals the pressure of the second side, we find that the force of the left side is equal to the force of the second side times the ratio of the 2 areas. Then the ratio being that the area of the top, area on the top in the numerator is going to be the smaller one from the left side. So we can find the force being applied on the right side on that piston, which is going to be equal to the mass, which is 1,000 kilograms, times 9.8 meters per second squared for the gravitational acceleration. And we find that that force is going to be equal to 9,800 newtons. So plugging everything in, we find that the force of the left side is going to be equal to the second force on the right side, which is 9,800 newtons that we just calculated, times the ratio of the areas. So 5.0 times 10 to the negative third meters squared being the area of the left piston, and 1.0 meters squared for the area of the right piston. And after you find that ratio and do some multiplication and division, we find that the force of the left side of the piston is going to be a pretty big value. I just put it in scientific notation, and that's going to be 1.96 times 10 to the 6 newtons. And just some of the tricky parts, I guess, were just trying to find an equation that you could use to end up solving for the force, and also knowing that the pressures are going to be equal for both sides, because the problem stated that the pressures are maintained. And this just relates to what we've been doing in class in regards to fluids and densities, and also the idea of pressure. So, yeah.